Through the receptors of the eye, color is perceived in the human brain. The human eye responds to light within a range of wavelengths between 400 nanometers and 700 nanometers. All other wavelengths are invisible to us. We sense the waves as color, violet being the shortest wavelength with 400 nanometers and red the longest with 700 nanometers. All other visible colors lie in the region in between. Three things are needed for color perception: a light source, an object, and the human eye. If light shines on colored paper, for instance, the colored paper fibers are the object. An object may both reflect some light and absorb some light at the same time. The reflected light is perceived as color by the eye. There are several options of dyeing papers. The dye is either added directly to the stock suspension or it is applied to the sheet surface, for example in the size press. In the majority of cases, internal dyeing is employed. This means the dye is continuously or intermittently dosed into the paper stock suspension. Today, liquid dyes are predominantly used, which are very easy to handle with dosing pumps. As far as raw materials are concerned, a differentiation is made between wood-free pulps and mechanical pulps, which still contain lignin and hemicellulose. For mechanical or wood-containing pulps, papermakers usually apply alkaline dyes, that is, positively charged salts of dye bases. After the dye has been introduced into the stock suspension, it spreads within the water in all directions. The dye molecules adsorb at the fiber surfaces. Compared to a fiber, a dye molecule is several 10,000 times smaller. In an aqueous medium, it is capable of moving in all directions at high velocity. The dye molecule adsorbs at the fiber surface, desorbs again, and readsorbs at another fiber. Thus, an adsorption-desorption equilibrium is gradually attained over time. This mechanism continues up to the process stage of sheet forming. Sheet forming is accompanied by drainage of water which restricts free movement of the dye molecules. The dye molecules now establish ionic bonds with the fibers. For wood-free papers, substantive dyes are commonly used. These direct anionic or cationic dyes chiefly consist of sodium salts of azo compounds with SO3H sulfo groups or carboxyl groups. Cationic substantive dyes form ion bonds with the fibers in a similar way to alkaline dyes. If an anionic paper fiber is to be dyed with an anionic dye, the water must contain certain amounts of dissolved alkaline earth metals, such as calcium and manganese. The anionic dyes will form complexes with the calcium or manganese ions. These complexes in turn adsorb at the fiber surfaces, are detached again, and readsorb at other fibers. Here too, an adsorption-desorption equilibrium develops over time. This mechanism continues up to the process step of sheet forming. Since water is drained during sheet forming, the free movement of the dye molecules is restricted. The complexes now attach to the fiber surfaces via intermolecular forces, such as hydrogen bonds or van der Waals forces. By selectively choosing Fastusol or Basazol dyes, papermakers achieve optimum dyeing results while meeting color fastness specifications.